Here's a problem, another projectile motion problem. A punter kicks a football with an initial velocity of 22.6 meters per second at an angle of 47.2 degrees with the horizontal. The ball leaves the punter's foot 1.47 meters off the ground. The ball is caught by the return man 1.15 meters off the ground. How long is the punt in the air? And how far is it from where the punt is kicked to where it is caught? Well, sounds like a projectile motion problem to me. That means I have to write down the projectile motion equations. So, start off with V naught x is equal to V naught cosine theta. V naught y equals V naught sine theta. So I've got those two. We can say that x equals x naught plus v naught xt. V naught x equals v sub x. All the time, it's constant. So got the x taken care of. Now the y equations I'm going to have to write on two lines. One thing I can say is v sub y will equal v naught y minus gt, and y will equal y naught plus v naught yt minus 1/2 gt squared. Okay, those are the general forms of the projectile motion equations, and our job is to try and apply them to this particular situation. So what we've got, we make a little sketch here. Horizontal, the ball is kicked from a little point above the ground. Here's V naught as a vector, 47.2 degrees. And then this little gap here is how high above the ground the ball is kicked from, 1.47 meters. And then it's caught by somebody downfield 1.15 meters off the ground. We can worry about that later. Well, let's figure out V naught x and V naught y. V naught x will equal 22.6 meters per second cosine of 47.2, which is 15.4 meters per second when you plug it into your calculator. V naught y is equal to 16.6 meters per second. Whoops, I already calculated it. Anyway, that was equal to 22.6 meters per second times the sine of 47.2 degrees. And so that was the result of that. It's not surprising that V naught y is a little bit bigger because the angle is a little bit bigger than 45 degrees, and that's where the sine and cosine happen to be equal. So we know that. And I'm going to let x naught equal 0 and y naught is going to equal 1.47 meters. That's where the punter's foot leaves the ball, or the ball leaves the punter's foot. Okay, how long is the punt in the air? Well, the punt is in the air until it goes up and over an arc and comes down, and it'll be 1.15 meters off the ground. I can take my y equation here and solve for a y value of 1.15 meters. So I can say 1.15 meters, that's y, is equal to y naught, which is 1.47 meters, plus v naught yt, which is going to be plus 16.6 meters per second times t, minus the old 1/2 gt squared. So minus 1/2 times 9.81 meters per second squared times t squared. Doesn't look like it yet, but it's supposed to be an equal sign here. This is going to be a quadratic equation. If I subtract 1.15 meters from both sides, I will get 0 equals 1.47 minus 1.15 looks like 0.32 meters plus 16.6 meters per second times t minus 1/2 times 9.81 meters per second squared times t squared. Okay, there's my quadratic equation. We can solve it as a quadratic equation. I'll do that first. A few days ago I showed you a program I'd written and put on this program, or put on this calculator. You can also download them there. But today I was poking around and it turns out it's built into this model of calculator. Then I'll show you to get to it. I don't know how well you can see that. Turn the thing on, go second poly solve, which is the text above the cosine button there, and it's got it'll solve a quadratic or a cubic. I'll go for the quadratic, so I just punch a 1 on here, and it asked me what is a. Okay, a is the coefficient of the t squared term, and it's going to be minus 9.81 times 1/2, let's see, that would be 4.905, and I'm going to keep that 4.905, although it probably won't matter. You could round it to 4.91 if you wanted to, but anyway, there's that. Enter. B is 16.6. Enter. C is 0.32, and solve. One of the roots is negative. All right. That would be, with this equation, it would be when on the way up, the ball happened to be at whatever it was, 1.15 meters above the ground. It's not very long ago. It's basically 2/100ths of a second. All right. And then if I hit enter again, it should give me the second root. Okay, x2 is 3.40 seconds, and I'll go with that one, or t2 in this case. So the time that we care about is the 3.40 seconds. That's how long it's in the air before it's caught by the return man. I don't think that's a very long hang time for a punt. The guy would have enough time to start a good return with a hang time of that long. So that was part A that I've been doing here. And then part B is, how far is it from where the punt is kicked to where it is caught? Well, that's in the x direction. So I just use my x is equal to v sub x, because I think somewhere I did define x naught to be 0 times t. So v naught x we figured out 15.4 meters per second and 3.40 seconds. And this is fairly straightforward, having to plug and chug this way. But it is a quadratic equation, and I don't give you those problems that require that solution on test. But let me show you something. I haven't used this calculator to solve quadratic equations before. Yeah, I get about 52.4 meters for that. By the way, this 0.32 meters added on to these things, even though this is only two significant figures, it's not going to alter this very much, because it'd be 16.92, and if you rounded it to 3 sig figs, or the tenths place, it'd be 16.9. So even though this is only 2 sig figs, because of the addition process, it's not going to alter the number of significant figures on either one of those. Okay, so that's how far downfield it happened to be. I'm going to stop there. The next two problems are going to be the crazy golfer wearing the spacesuit. So we'll see how those work out.